This conference will now be recorded.
All right, I'm gonna give it just one more minute for everybody to finish logging in so we have as many attendees as possible when we kick this off. Steve is going to get started, but first, just letting everybody know, Steve, yourself included, right before we get started, I am going to mute everyone. So Steve, you are going to have to unmute yourself really quickly, just to eliminate any background noise. In addition to that, there is a chat function that you guys are all able to put your questions in. At the end of Steve's presentation, he'll take a quick pause. He can answer any questions for you guys. And then after the end of my portion of this presentation, I will also pause. But at any point in time, please feel free to put your questions in the chat there. And now I'm going to mute everybody and I will let Steve get started.
Hello, everybody. Steve Richardson with Forecast 3D with PostProcess and Francesca, talking about expanding prototyping possibilities. Very exciting opportunity here, and really looking forward to discussing for a few minutes what we see. We're going to go through a little rundown how most people view 3D printing. The MJF game changer is really what I believe in, and a case study that's going to show how we work through this process to really expand your prototyping possibilities. And then post-process will go into the way that they will work into the value stream to improve that flow. So a little bit about Forecast 3D. I think it's important for everybody to understand where we come from and what our makeup is. We're an American craftsmanship digital manufacturer. And I stress digital manufacturing because in my mind, there's something different between, say, prototyping and actually going to manufacturing. We've been around for 25 years. And you know, we're going to talk mainly what we brought in 2016, which was one of the first early adopters of the HP multi-jet fusion. So we are leading that path. There's a picture right there that you see of our MJF facility where we house an ecosystem of 31 HP MJF machines running all materials. Because of our background in polymers, at the end of 2019, we were acquired by GK Powder Metallurgy out of Germany, who focuses on AM metal. And this really has given us that opportunity to expand our footprint, still supporting our local partners, but moving globally. And I think this is really key, especially in the MJF technology, especially everything that's happening in the world right now of regional manufacturing. So let's get down to it, right? Expanding prototyping possibilities with MJF. Here's a picture of a product, and there's hundreds of them there, right? Well, how do we get to production, right? How do we expand our prototyping possibilities? And it's a mindset shift. And for me, I have a supply chain background, so I look at things a little bit differently, say necessarily than an engineer. I'm looking at how we can bring this to production. And so I look at it as a production opportunity and backing into our prototyping possibilities. How do most people view 3D printing? Me, as well as probably everybody who's on this call, has had a call or discussed with somebody about 3D printing. You know, I was on a webinar the other day, and 84% of CEOs know they're doing 3D printing, and they want to go to production, but they don't really understand because there's an education missing. Because traditional manufacturing, the way that we've been doing it for hundreds and hundreds of years, we design, we create a tool, we cut a tool, then we get it into production, and then our cost, our per unit cost goes down dramatically. And everybody forgets about everything we've done before leading up to that point. They're only focused on that per piece price in production. What happens is once you get into once you're done with production, you're in the end of that life cycle of that part and you're through the value stream and you're now into inventory and MROs, what happens? That cost of that part goes up or you can't supply it anymore. Most people think that 3D printing is simply sending that file to the printer, pushing play, and it comes out. And we all know that this is really how 3D printing to me, as I was saying, is prototyping, but leading towards that production. But with MJF, the game changer, right? It's the same technology in the sense that we are still doing 3D printing. We are still building something, adding and printing. But in 3D printing for prototyping, we are strictly quick and dirty. That's what we look for, right? We want a part in our hand so we can touch it, feel it, see how we can tweak it, and actually get a good rendering of what's happening with that part. With the MJF game changer, as I call it, we now have an additive manufacturing experience. Now, listen how I changed that to additive manufacturing experience. Because in order to do manufacturing and take MJF and 3D printing into production, we have to have a controlled, repeatable process. And you're gonna hear me say this a few times is MDC, MDC. Now think of MDC and this is what it means. We are always gonna be looking for our mechanical, our dimensional, and our cosmetic requirements to have a controlled process to take our product into production. As we align and we move through this channel, through our prototyping stages and our MPIs, we have a real opportunity with MJF to have full production with manufacturing experience. And the reason why I say that is, but when in that manufacturing experience, what you need to look at is the entire value stream and how your MDC, right, your mechanical, dimensional, and cosmetic requirements fall into this. Because through your inputs and your pre-processing, 3D printing and additive manufacturing is more than just printing. So many people think that it is strictly printing, right? But we know that in the post-process, which is where a lot of IP is held for a lot of digital manufacturers, because it's more than just printing. It's how you process that part after the printing to give the end result to the customer that you will ship. So there's a lot to play that we have to think about in this, right? Because really, additive manufacturing, this dotted line, the total cost of part is brought down with that alignment at the beginning. But if you see through production on the right with MJF, we actually have something that can have feet that can actually move through that process, right? Our cost of setting up, we no longer have tooling. We don't have to wait 6, 8, 12 weeks to have a tool cut. We don't have to drop 20, 30, 40, $100,000 to have a tool cut and then wait to see if our product is gonna be okay before we make more adjustments. This is so important, especially right now, because the state of the world and everything, I feel that there's gonna be a big onshoring from the States bringing manufacturing back. And what we need to do is find parts and applications that allow us to implement MJF in polymers, in nylons, right? And find out how we can have that cost all the way through the life. Now our aftermarket and our MRO, we have that fixed cost all the way through and we don't have to worry about tools. So it really comes down to understanding, right, those cost drivers. And first, mechanical, right? Mechanical of how are we going to do it? We need to look at the materials that are offered to us through MJF, nylon 12, nylon 12 glass bead, nylon 11, polypropylene, TPUs, right? The MJF is further behind than say an SLS, but the materials are coming and the applications are there. But if we look at the material and then how our dimensional and cosmetics is going to directly impact how we orient the part in our build platforms or our packing density. And as post-process, we'll go into more detail of how do we suck out some of that labor cost to bring production back, right? And still be able to post-process and have that throughput. But it all starts with figuring out the material, right? the mechanical dimensions of what the mechanical strength and properties that we need in order to build our product. And as you see these images below, these are all parts that were built in MJF by looking at it on the mechanical, dimensional, and cosmetic requirements, because there are certain parts or certain areas of parts that we do not need to have 100% cosmetics. Everyone's not going to see it, but it needs to be dimensionally sound because it's mounting to a subassembly or something along those lines. So I think the best way to really think about this is to really work through a case study that Forecast 3D worked with, and understanding how MJF and that expanding your prototyping possibility, right? It comes down to understanding that in order to use MJF with our MDCs, we need to figure out the balancing of our engineering requirements with what we need to deliver to the customer, right? So we have to go through these steps of scoping, designing, prototyping, everything that you would do in traditional manufacturing, but that timeline is condensed. And sometimes this can happen in 2 weeks, sometimes it can happen in a week. It really depends on the product. This is a more complex product that we worked on, the CGX, right? This wireless headset. Looking at it, you're like, it's pretty clunky, but it holds a purpose, right? So CGX came to Forecast 3D, and we went through this product with them. Now you see this very organic looking, pretty cool looking device that somebody wouldn't mind putting on their head, right? And we have to understand that if somebody's putting it on their head, there's obviously that they're doing some analysis and some medical studies, and so we need to make sure that it fits properly. There's biocompatible and everything like that. So what we had to do originally is that scoping and planning, looking over the whole product with that customer and that design team, and seeing and understanding and aligning what they're looking for and what we need to accomplish. Looking at our materials, right? Our mechanical side of things, and looking at what do we need to do in order to align. And then what really holds up a lot of prototyping jobs, I think, in going to production is understanding the business requirements. The quality side is, this is what I want to print. You printed it, you shipped it to me, but is it exactly what I asked for? We have to understand the quality side is key there. So in order to do all this, we were able to actually identify 40 parts that we could do in MJF in 2 materials, the PA12 and PA11, and we were the manufacturing partner with the expertise. But in doing that, we designed this casting, and this was the original design from the customer, into this fine-tuned, organic-looking, beautiful headset. Different colors, you can see the different bends, all done by scoping with the customer. Even going a step further and looking and seeing that in part of the application, by moving it to MJF, there was a weak spot. We can make that slight tweak, improve the quality of the part, and reduce or mitigate some of the errors that may happen in when it's being placed on the head and breaking, right, just from being worn. But by looking at these parts, and like I said, the dimensional and cosmetic requirements, each part is different. This part here needed high accuracy, so we need to adjust how we orient it in our build. This part here had, needed ductility, and it had to be affordable, and surface finish was, but the accuracy wasn't as important. So that we looked at in its own. This part here was strictly, we need the price. It's a part that's probably consumable. It's all the parts coming on and off of the actual piece of equipment. We just need the price point. But what this allows us to do is we can take all that time here. We just need a price on this one part, and we can take that energy and focus on one of these other items that maybe need high accuracy. And the way that we orient it, the density that we use, and our post-processing is really what allows for these things to happen. We go through the testing, right, and the stabilization before going to full production in order to make sure that our cosmetics are met, our dimensional stability is met, right? Any biocompatible or any surface finishes that need to be done are being met. And what this does is allows us to take this prototyping mindset and really with MJF, which I strongly believe in, that multi-jet fusion is the way to production. And it allows for and improves the cost and the quality of the part. But we have to align at the beginning in order to make sure that we meet our MDCs, that mechanical, dimensional, and cosmetic requirements, because really in the MJF technology, there's so many different ways that we can look at that and orient and spin it, that you have to do those test studies in order to take it to full production. And when you do, you have, as an example, a result like this, where 40 individual components were produced in MJF over this whole device, meeting the mechanical, dimensional, and cosmetic requirements. And it allowed for a product that can not only go into small production, but then can also move through full production when it gets legs. And that, is there any questions? I said that.
All right, great. Thank you so much, Steve, for that. You're actually going to be hearing a lot of the same words that Steve used when we're talking about repeatability and giving you, that cosmetic upper hand when we're talking about post-processing. Again, if you do end up coming up with some questions that you have for Steve, please feel free to throw them in the chat and we can get to them later. Additionally, we can reach out to you after. But what I'm going to cover today is, what typical MJF surface finishing looks like. And then I'm going to introduce to you a new solution for surface finishing, which is PostProcess solution. And then we're going to go over some ROI and case study examples. And this is really just to sort of help you visualize some different circumstances, and hopefully you should be able to relate to them. But quickly getting started with who PostProcess is. So we were established as the first comprehensive solution provider for additive manufacturing's post-printing needs. So our goal is really to help additive manufacturing scale to its fullest potential. So we do have a range of patent pending machines that run our proprietary software and chemistry. And we provide post-print solutions across all additive manufacturing technologies. That's why you're seeing these different technologies here. Moving forward, we are just going to be talking about MJF surface finishing. But I will talk about some future virtual events where you can learn about some of our other solutions. So when we're talking about the problems seen across the entire additive industry, it's really with these traditional approaches that everybody is taking to solve our modern problems. So really anybody utilizing a traditional method such as manually hand sanding or picking, or a traditional manufacturing system like a vibratory tub, you're quickly going to realize that this process just can't be scaled. So because of the time-consuming nature of each one of these methods, it reduces the amount of parts that you can post-print, and this in turn is going to create a bottleneck for your throughput. So as you continue to grow your production, the significance of this low throughput is also going to grow. So in addition to this, your parts are really going to dramatically vary in quality due to the inconsistent nature of just sitting there and hand sanding parts. So all of these pain points wrapped together make for ineffective and costly processes that result in drawn out ROIs for your printing production. So now I'm going to dive into some of the specific pain points that you'll likely be able to relate to if you've done any of these traditional methods of post-processing. So specifically focusing on the problems that arise from traditional post-printing techniques, such as a vibratory system, you can see how a traditional vibratory system would be really hazardous for more complex geometries. Because these systems haven't been designed specific to additive materials, they lead to wide inconsistencies as well as damaged parts, or at the very least, because MJF parts do have really great mechanical properties, you are going to be wearing down these fine featured details in these traditional machines. Even after spending all of that time with those vibratory systems, you will not be seeing the same amount of consistency that you would with a system that's designed specifically for these materials in mind. You're going to be experiencing long cycle times, and these just are really going to start drawing out your whole process and creating that bottleneck that I mentioned. And then when we're talking about manual sanding, you're never going to be able to have the same consistency from person to person, day to day. It's always going to have that bit of, human error involved in that. And not only is there going to be that inconsistent component, but it is really time consuming for the technician. And, just relying on the availability of that manual labor, you can only, be productive in the hours that people are there. So taking this work, out of somebody's hand and putting it in a machine is really what we came to do. And we do it in a really unique way. And this is the combination of hardware, software, and chemistry. So each one of these components were specifically designed with MJF materials in mind. So if you are using some of these traditional methods, you're likely sourcing some of these components from different vendors. So this is creating more work for you, on top of the fact that these components are not designed and tested to work together specifically for MJF surface finishing the way that our solution is. So now there's a really high-level benefit summary slide where I'm going to dive into each one of these benefits and how specifically our technology does that. So getting started with how to increase your throughput, the key to increasing your MJF throughput is by introducing automation into your post-process production. So we are able to shorten cycle times by 80%. So you're able to now print and post-print more parts with a software-controlled solution. So that 80% is tying into that 5 more parts number. So in the time that it would have taken you to run 5 cycles, to run 1 cycle in a traditional system, you could have run 5 cycles in one of our solutions. In addition to that, our technology has really been thought through specific to the materials that we are addressing. So we utilize a proprietary detergent, an abrasive media specific to these materials, and then a vibratory circular motion to apply an even mechanical force and maintain uniform contact for the whole cycle. So the level of control that our software allows over these energy sources with real-time process monitoring is especially important for the range of materials and geometries that we typically see with MJF printing. So now you're going to be able to print and post-process more complex and delicate geometries because of the fact that all of our processes are designed with the materials of additive, the cosmetic issues and the textural issues that we're seeing with those print technologies. We can address all of that while keeping the integrity of the part intact and reducing your risk of breakage. And on top of that, by lowering the amount of time that anybody's spending either checking on a traditional vibratory machine, hand sanding the parts, we're going to be lowering your labor cost and freeing up your time to do more value-added work. And so I talk about this comprehensive approach that we've taken. So with each layer of this, we've designed it really with the user in mind to make it extremely simple. So the software component is extremely intuitive. It has a simple interface with a smartphone feel. You can see what your process is undergoing, but it's really just as simple as pressing a play button and letting the machine do the work. The machine is going to provide proactive maintenance warnings so that you can plan ahead for downtime, and then we can quickly adjust so that you can keep changing for different materials. So maybe you're swapping from, maybe your typical more robust MJF part to maybe something with some more fine featured details. We have the ability to adjust our cycles to adjust to those changes in your processes. So then when we're talking about the improved consistency, really the key here is the fact that our solution is software based. You have repeatable results, something that Steve mentioned earlier, that's always going to be able to, you're never going to have a different person giving you different results. No matter who's pressing play, no matter what's going on in that day, you're going to have the same results from person to person, batch to batch. And now that person's time is going to be able to shift to more higher value operations. So we were able to achieve roughness averages of less than 2 microns while maintaining the integrity of edges, resulting in surface losses of less than 0.1 millimeters. So really all that means is that, we can give you a really smooth finish without compromising the integrity of your structure. And if you want to learn more about the specifics, so I know I got a little bit into some information, a couple highlights such as that 80% total reduction within 4 hours, and then 5 times faster than a traditional tumbler. So all of this information and more is available in our latest white paper. So you can click this here now and it will take you to that download, or additionally, we will make sure that a download link is available for you. And all of our white papers on our other technologies are available at postprocess.com /white-papers. So now finally, I'm going to talk to you quickly about an ROI, but I want you to understand exactly what we look at when it comes to calculating an ROI. So a few of the key numbers that we look at are going to be your labor cost, how much time is spent finishing each part, and in turn, how many parts are damaged during your traditional method. Then we take this in comparison to what your post-printing would look like with our solution, and then this results in your ROI. So this example that you're seeing here, the customer was printing 30 parts per day. They had a labor rate of $30 per hour. So they were doing hand sanding. So for every hour that a customer was spending hand sanding, that was $30 down the drain. So we were able to decrease the operator time from 10 minutes to just 5 minutes per part. And we also changed how many parts were rejected. So they were having 1% of parts being damaged, and we got that to just 0.1%. So that resulted in saving just under $5 per part and resulted in a 30-week ROI for our Rador. So while we do have 3 different surface finishing solutions, the one that we are really focusing on today is going to be our Rador. So you're looking at it here. You can see that part envelope. I won't read that to you because I know that can get a little bit annoying. But I'll take a moment and you can see the size of the envelope, but the size of the part guideline so that it can properly function in the technology and that circular vibratory motion. That's the size that you're seeing here with that graphic. And then lastly, to really wrap things up, I just want to summarize the transformative benefits that you can see by switching to a post-process finishing solution. So by introducing software to your process, you're really going to have the consistency you need to optimize and plan your workflow. We remove the bottleneck created by allowing you to batch your parts without risking breaking them. And then finally, we free up your time by reducing the amount of tedious manual labor in our solution. And we allow you to accelerate your process really from end to end and free up your time so you can do more valuable things. So that's all the content that I had prepared for today. I will leave you guys with some upcoming events. So on my end of things, I have a Link 3D AM marathon. So we'll be talking about producing customer-ready parts and navigating the leap from prototyping to production. And as well, we are in collaboration with SME hosting a webinar regarding the next step of additive manufacturing productivity, and that's automating post-printing. So we do have a link down there, that postprocess.com, where you can see our other virtual events that are coming up. For Forecast 3D, Steve, if there's anything that you want to add about that.
Yes, we'll be part of the Link 3D AM marathon that everyone's been hearing about, as well as we're going to be working on a podcast with SME. So you can go to www.forecast3d.com, check us out, and we'll be happy to help you out.
Okay. So really quickly before we get to questions, after this webinar, you are going to be receiving an email with a link of this recording, a link to download our white paper, and then a link to a survey so you can let us know what you thought. We're probably going to be hosting virtual events for quite some time now, so your input is really valuable for us to make these impactful as possible. All right, so we have contact info down. Write that down if you guys have any specific questions. But in this moment now, if anybody has any questions, you can enter them in the chat. I know we are right at the end of our time, so I will take the time. Thank you, everybody, for taking time out of your day. If you do have a question, I will stick around for just a couple more minutes. Okay, I had a quick question here regarding powder removal. So what we were talking about today is surface finishing post powder removal. So this is a cosmetic process. Steve talked a little bit about cosmetics. So this is really to help the feel of your part and help it, just be a little bit better for your end consumer. Okay, I have a question here, if this can be used for other technologies. So yeah, one of the really great benefits of this solution is the fact that the chemistry is really just there to act as a lubricant as well as to wash away any broken down media. So a great thing about that is that if you have MJF and FDM printers and SLA printers and you all want them to have a better finish, then you can throw them all in the same batch and they won't, the chemistry isn't going to do anything because it's really just acting as a lubricant. Okay, so I have a question here regarding will it seal the part? So you have the choice as to how, what level of finish that you have. So we have guidelines that let you know at what point do you start to seal the part. So if you're thinking about dyeing as a next step, our machine can be used as for a finish, and then you can move on to a dye step, so it won't seal it off from that. However, if you do want to leave it in the machine for that more sealed finish, that you also have that option. So I have a question here regarding how many materials can you surface finish. So honestly, we have done all materials across all technologies, metals, polymers, even the most fragile materials we are successfully able to finish. And the key to that, we change the media. So the abrasive media that's doing the finishing and acting as, that little bit of sandpaper, you can adjust this. So we really haven't run into any issues other than, those rubber like polyjet materials. Those are a bit of a challenge because the media just sort of bounces off of it, but we're not typically seeing finish requirements with those processes anyways. I have a question regarding a comparison against AMT and dimensions. So we don't have an AMT or a dimension solution in-house. Obviously, we have our own post-processing. So we cannot speak to the results in their machines in comparison with ours, but we can give you data with specific numbers that are available in that white paper that you're going to have the link to. So feel free to take that information and compare it to them. Okay, so how will these techniques transfer over to metal jet printing when this becomes available? So it's going to be the same thing. We're just going to swap out your media, let you know that your cycle time is going to change. It's really a great process regardless of what your material is. I have a question here. Can you do desktop metal stainless steel 316? Yes, we can. So again, just selecting that media. We also have the ability to, you can send in your parts and your materials to us. So that's going to be getting in contact with post-process. We'll get you in contact with one of our business development managers, and they'll talk to you specifically about your parts, materials, and then potentially we can bring those in-house and finish them for you. All right. I think that about wraps things up. Thanks for everybody who stuck with me for the extra couple minutes for questions. Steve, thank you so much for working with me on this, and I look forward to seeing from Forecast 3D.
Thank you. I appreciate the opportunity to present with you.
Yeah, of course. Perfect. Have a great day, guys.